All right, cool. So Timeout Classes, the question is, we create a class and we are overriding this init method, but how does that work? So when you create a class in Python, so I could just do this. And it's kind of like the minimal class in Python. So this doesn't do anything interesting, but it exists.
Do you mind sharing your screen again?
Oh, sorry, I'm not. My bad. So here, this is kind of a minimal, like, the minimal class in Python. So when you create when you create an instance of a class, so I like to think of classes as templates or forms. So if you go to the DMV and you want a driver's license, they don't just hand you a blank piece of paper and say, okay, well, give me a bunch of information that you think I'll need to give you a driver's license, right? They have a form, and the form has, a box for your name and your address and everything else, but it's not filled out already for you, right? You have the form, and so I know the fields that I need to put in, but I have to fill that in. So the form is like the class, and the form that I fill in, Chad Mowbray, go to the DMV and fill in the form. That's like an instance of the class. So when you have this template or form and you create an instance of it, Python is gonna, under the hood, actually run through a couple things. It's actually gonna call a few methods implicitly under the hood. And it's gonna do that so it can kind of create the instance for you. You usually don't need to worry about that. And what we know right now is the def init. So let's do this. And what I'm going to do now is I'm just going to print, for example. So I'm not really going to do anything here. I'm just going to print it. And there's a couple other methods. I forget what all these take, but I might have to do something else here. And then there's actually a delete. So I'm going to create an instance. Okay, so I've defined this class, and I've created an instance. I think this is going to break, so I'm going to have to do something here, but let me check this out. So notice that new was called first. And I'm going to have to return, let's see. Don't worry about this right now. Let's see if this works. Okay. So don't worry about this right now. But what's happening is that all I did was create an instance. You can see that under the hood, Python has done a few different things. So to create it, it's called new. So it calls new first, actually. And this is actually where you're going to get the instance. And then init is the setup. So for example, if we want to define, instance variables or whatever, that's going to get set up here. And then delete is called once it's no longer in scope. So Python will clean up for you, basically. So you can create something, and then when Python, don't worry about the Python takes care of that for you. Other languages, you do have to manage that in very low level languages. But you almost never have to worry about what's in new or delete. But what's in init, you do need to worry about. So this is a common thing to override. So when I say override Python, so we can see here that Python is actually calling all of these methods, right? And we are overriding them just so we can see that Python is actually calling them. But if it weren't calling them, so I can have another method here called, and that one's not going to get called, right? Because no one's calling it. But implicitly under the hood, Python is actually calling all of these methods. So does that answer your question?
Yeah, that definitely answers my question. I thought it was interesting that Python is able to like, it must have like a built-in scan to look for new, because procedurally it should hit init first, but it hits new first. So that's interesting. And then the other thing I wanted to ask is this double underscore. Like if you did whatever double underscore, would that run without a call?
No, that's a good question. So the underscores are basically for built-in Python stuff. So you can do this obviously, but you would never do something like this in practice. So there are other you can maybe look at this later, not right now, but so things like well, why can you how do you iterate over a list? How does that work, for example? Well, there's actually a double underscore method called iter, and there's a couple other related ones. And these are built-in methods that when you're in a for loop and you're running when Python is running the for loop for you, it's actually calling these other built-in methods. And you can override that. You can build your own data structures that you can put into a for loop, and Python will just treat it like it's its own built-in thing. So that's one of the cool things about Python. It kind of gives you access to the lower level stuff, so you can write your own custom classes and objects that can behave like native Python stuff.
Awesome, thank you.
Yeah, but you don't really need to worry about that right now. Okay. All right. So I think that's. Does anyone have any basic questions about what a class is, or what an object is? I know it's still confusing, but all right. So I'm gonna get rid of that stuff. All right. So what I thought we could do for today is today's supposed to be about more testing, some more testing stuff. So last Saturday we did testing in JavaScript and we used Jest. Jest is just one option. There's a whole bunch of, you can do your own custom things. Testing has a lot of different levels. You can just kind of run ad hoc tests. You can try to gather those tests and put them somewhere else. You can try to write your own library. You can use someone else's library. But the important thing is that you're writing tests and that you're thinking about as you're writing your programs, you're thinking about how can I test this? So I'm going to go ahead. I'm going to go. Excuse me, I'm getting over a cold. So I'm going to go here and I'm going to go through the process. I'm going to fork this over and clone it. And then I'm going to solve the credit check. I'm going to use a class. So I'm going to structure it as a class. And I'm also going to use Python's unit test library, which we'll look at in a second, to write tests for it. All right, so first thing I'm going to do, I'm going to fork it over to my repo. Okay, so now here's my copy. So I'm going to now clone this. Okay. So I unfortunately, this is not maybe the best convention. I have, I already created a directory called credit_check, and now in that I have credit-check. You might not want to do that, but so be it. So in here I have Python, so I have creditcheck.py, which is set up to be a function, but I'm not going to do it that way. And then here's some tests. So I'm going to write my own tests, and I'm going to write this a little differently. Okay. So if we're thinking about solving this problem, can anyone describe what we're supposed to be doing here? What is the problem?
Basically, we're validating a credit card number, if it's a valid
Okay.
credit card or not.
All right, cool. So so at a high level, what would be getting as input for this?
It's a string of numbers, right?
Okay. String of numbers, and what is our output going to be?
I think it's a string. It tells you either number is valid or invalid.
Yeah, it's a little where is that? It's a little awkward, maybe. We're outputting a string. Yeah. So here in the test, so the when we're looking at the description of the problem, it doesn't actually tell us that, right? It just says basically we're validating it. But if we look at the tests, we can see that specifically, okay, so here's a string. We're going to get one of two strings. So I just want to note that figuring out, so these are all the problems that you get through this course. Obviously, we're kind of building you up to be, independent functional software developers. But a lot of what you're going to be doing on the job is figuring out what the hell the problem actually is. So here we're kind of telling you, here's the problem, and here are all the rules, and blah blah blah. But the actual problems you're going to be solving are more like, we think that something might be broken over here. And so your job is to figure out, well, is it actually broken? Who owns this? Am I allowed to touch this? Do I have to fix something else to fix this first? And all kinds of other things. So being able to start with maybe an inadequate or even wrong or confusing description and kind of work your way into understanding what the problem is and then how to solve it. So that whole process, as frustrating as it can be, is part of the show. Okay. So we know that we're going to get a string of digits in as input, and we know that at some point we're going to basically return one of two strings. So it's either going to be valid or invalid. And then what about at a basic level? This is the stuff in the middle, right? So what's the stuff in the middle? You don't have to give me, extremely detailed answer.
It's just an algorithm.
Okay, it's an algorithm. Looks like there are a few different stages here.
So you times every other digit by 2, and then if it's over 10, you sum each digit within the number over 10.
Yeah. So we're going to take this thing, whatever we get as input, we're going to multiply every other, or double every other, and then for those, if any of those doubled numbers are over 10, we're going to add the two digits together, and then we're going to add up the last step. We're going to add up all of them, and if it's divisible by 10, then we know that it's valid. So there's several different steps involved. How many of you solved this? For those of you who solved it with one function? Or maybe a better question is, for those of you who solved it, how many solved it with more than one function? Yeah, so I would say that that's not, it's fine. If it works, it's fine, but that's not going to give you a lot of visibility into what's happening. So for example, if something ends up being wrong with here, with this, for example, you have a problem. Where exactly is the problem? What if this requirement changes next year? There's a new algorithm and you need to triple every other digit instead of doubling it. Yeah, so there's all kinds of things that can happen. It's best to separate out elements to make them testable and easier to modify and reuse. All right, so let's try and do something like that. So we want to have a class. And before we start just writing stuff, let's think about the methods and data, the variables that we need, the data that we want an instance of credit check to have, and then the functions or the methods that we want it to have. So I think we can start with the methods. This should be, I think we can kind of just basically look at these, right? So we somehow are going to have to double every digit and then sum the digits. And so let's maybe write that out. I'm just going to stub these as methods. So, well, I'll go ahead and write out some pseudocode first. So, we're going to do sum. Okay, we're going to sum every other number. And another method we know is going to add you're going to add the digits for numbers that are over 10, or is it over 10 or over 9? Yeah, so over 9, so 10 and above. And then what other methods might we have here?
Need to sum all the numbers together at the end.
Okay. Anything else?
Then check if it's divisible by 10.
Okay. Anything else?
Maybe print the message.
Yeah, so we have to somehow. So we can figure out, I think this is a good start for now. So those are the methods. What about the attributes, the data?
The credit card.
Okay, good. Yeah. So we know that, every every instance of credit check is going to need a number to check. So the okay. All right. Well, let's start with this, and if we need to revisit anything or add or change, we can do that. But I think this is enough to get started. All right. If I zoom out like this, can you guys still see it? Is that still clear? Can anyone not see that when I at this level of? Okay. Please let me know if that's the case. This gives us a little more room to work with. Okay, so I'm gonna go ahead and stub these methods out right now. So def init. Okay, so what have I just done here?
Initialize the functions that are going to be passed into the class.
Okay, so is card num a function?
Well, it's a parameter right there, but it will be a function, right?
I think this is just gonna be the string. This is just gonna be the like this string we pass in, string of digits.
Did you just add an instance attribute?
Yeah. So what we're doing is we're getting just a parameter. This is like a local variable, and we're saying I don't want you to just be a local variable. I'm going to assign you to the instance. And when you do this, you make it available anywhere in the instance. I could just do, card num or print card num or whatever here. If I did that, let me just do. I'm going to go create an instance now. How do I create an instance of a class?
Assign it to a variable.
Okay.
Credit check and then open parentheses.
Yeah. And then this needs a parameter. So I'll just do for now. And then I'm going to try and access card num now. So how do I access card num?
You can do cc dot card num.
Okay. So before I run this, is this going to work?
Will that just give you the memory address? No, I think it's going to work.
Anyone think that it's not going to work?
It'll throw an error because card number is not defined, right?
It's not defined. I mean, card numbers, I can see it right here.
Oh yeah, my bad. Never mind.
Okay, well, let's see what happens. Actually, I got to make sure I'm on the right level here. Okay. Oh, I did get an error. So what is the error?
The object has no attribute of card number.
Yeah. So what object are we talking about?
The CC?
Yeah. So this instance I've created telling me that it doesn't have an attribute called card num on it. Well, why doesn't it have an attribute called card num?
Because we didn't say self that card number equal card number.
Exactly. So I can see that it printed out successfully, right? So I created an instance here, and this actually ran fine. So there's no problem up to here. So this all works. The problem is on line 20, I'm expecting this instance to have a property called cardNum, but I haven't assigned the instance a property called cardNum. So what I have to do on line 16 is actually assign the instance a property called cardNum. And then when I do that, it works and there's no problem. So that's what we're doing here in this init. We're saying whatever value you pass in here, I want to assign that value to the instance so that I can access it later, which means that not only can I access it here, but also within the class, I can write methods that can also access this. So let's try just to look at that real quick. So def this one's going to be a little more. The linter is going to help us out here, but so here, if I comment out this line, which errored last time, what's going to happen if I try to call, sorry, cc.print cardinal?
That should give you card num
Okay.
because it prints the message. Yeah.
All right. Any other guesses?
It's not going to work because we can't access card number since it's not defined anywhere.
Okay. Let's see what happens. Okay. So we do get an error. And where is that error occurring?
19.
Okay. So it looks like we have we also have
23
to
and
line
19.
23. So what's going on there? Why do I have two different line numbers?
23 is where the call to the function happens.
Yeah. So this is called traceback or a tracks, a stack trace. But so often your error messages are going to be not just one line, but I called something which threw an error, and you had called this, and then that, and then that, and then that. So here's kind of the chain of calls. So the actual error is occurring on line 19 when I'm trying to access this variable, which doesn't exist within this function scope. But that function is being called on line 23. So this function is calling this function, which is trying to execute this, which is throwing an error. So you work your way from the bottom up when you read error messages. Okay, so but I see it right here. It exists. So why is this not accessible?
So then the function refers also to the attributes that are defined for all instances. So then we have to have the self card num again.
Yeah.
Okay.
Yeah. So this right now is just a local. This is just a local variable inside this method. So I can't just access local variables from other functions inside other functions, right? So we have to put this in a common namespace or common, basically namespace, an area where both of these methods have access to them. And that's another reason why we do self.cardinal. So it's not only this instance out here we can access it, but internally we can also access.
Well, if you wanted to just print any other message, that will work, right?
Yes.
The function itself.
Yeah. But now we're saying the instance is card num. So it's not just card num, it's the instances card num, because I've assigned it here. I've basically pulled it up out of this function scope into the instance. So now anything in the instance can access that. Okay. So let's go back here, and I'm going to add some of these methods. So def some and we could revisit these names if you'd like. Yeah. No. Well, yeah, anyway, well, we'll do this. And then okay, so now we've got some basically have a skeleton now for our class. So it's gonna have to do, we're gonna give it a credit card number, and then at some point we're gonna want to display a message. And then all this other stuff is kind of processing. That's how we're gonna get there. Okay. Why don't we tackle this one first? So sum every other. So if I have, what data type is card num?
String.
Okay. Is that going to be a problem for us?
Eventually, when we have to add them.
Yeah. So if we think about our data types, we may want to. So is there a better data type? If we look at all of these.
So we need to convert it to an integer.
Oh, sorry, a list.
Okay. So we have a string, and maybe what we want is a list of integers. I think let's go with that. So I think we're gonna have to write another method.
And I think it's really important to point out that it's going from right to left for the numbers, every other number.
Okay. Yeah, that's a good, let's take a look at that. So here in this example, we have 5, 5, 5, 5, 5, and we're doubling every other. So does do we need to start from the reverse?
We could just reverse the integers in the list.
Yeah, we could reverse the integers in the list. Do we have to reverse them?
You can decrement backwards.
How's that?
I was saying we could also decrement over the numbers backwards.
Yeah. So if we're using like a for loop or something, could do that. Could we?
Maybe just the odd number, or the number in the index that are odd.
Can you say that one more time?
Or like maybe not reverse it, but just like it, just get the numbers that the index are odd.
Yeah, exactly. So we definitely could reverse it. And that kind of makes sense with the description, right? That makes sense with the description. So every other, so we think of that as like, here's 2, 4, so that makes sense. But we could also potentially not reverse it and just use the odd number. So 1. So that may or may not be a problem. That's kind of like a question. I'm not entirely sure what the right answer is there. It might entail, domain knowledge if this were, a real credit card number checker or whatever. This is something you probably want to look into. Maybe it makes a difference, maybe it doesn't. But I think based on what we have here, it probably doesn't make a difference. Would there be a reason to prefer reversing or not reversing?
I mean, for me, just because in English everything's left to right, so intuitively, I think that I would just prefer to see it that way if I were writing it. So I'd probably lean that way.
Okay. Yeah, I mean, there's definitely a case to be made for like intuitive, it being more intuitive. What about?
As long as the amount of numbers doesn't change.
Yeah. So our decision does involve some domain knowledge, which I don't really have right now. But I'm just gonna assume that it's indifferent. I'm gonna assume that it's gonna be exactly like this, and that's not gonna change. So if I assume that, I was trying to get at the issue of runtime complexity, which we haven't really talked about. But in general, you want to not do more work than you have to. And if you reverse a list of numbers, here we only have, 10 or something numbers. But when we think about complexity in programming terms, we think about like, very, very large numbers. So if this scales up a lot and all of a sudden we're dealing with like 1 million numbers in our list or something like that, then doing that, reversing that, 1 million numbers in the list, 1 million lists, that kind of stuff starts to add up. So I would say that if we don't have to do something, then we probably shouldn't, but there's definitely arguments to be made either way. So I'm going to say just for now, let's go ahead and not reverse it. And let's focus on converting to list ints. So I also just want to note that, there's often times in programming where there's maybe not a clear right answer or clear best way to do it. There's a couple possibilities that seem very similar. So yeah, okay, so convert to list ints. How can we take a string of hopefully digits? Let's not worry about validating input. Let's assume that they're all going to be string of digits.
I mean, you can iterate through and then just save them as an integer in a new list.
Okay, so I can iterate through. Okay, good. So I could do like for char in self.cardnum, and then I can maybe create a new list and append all those to a list. So I could definitely do that. But that's a little boring. Have you guys seen list comprehensions? Okay. So we can do this with a list comprehension pretty easily, I think. Anyone like to take a guess? How can we convert this using a list comprehension?
Just do list and then open and close parentheses to the string, the card num.
So yeah, so there are a few ways to do this. One is the for loop and an appending. The other is to create, to use the list constructor. which will automatically break up that. But I'm gonna show you this. I'm gonna do so here is a list comprehension. So this is going to return me a new list. So it's going to iterate over every single element in that string. And then it's going to create a new list with this. So it's going to be a bunch of whatever these are. And if I just do it like this, it's actually going to return me a list of strings. I don't want that. I want to convert these to integers. So I'm going to cast each character to an integer. So this should return a list of integers. So I can test that out. You can do cc dot and that should just be yes. If I print this out, what degree this works? It works. I think it works. How can I be sure that it works? Can other people be sure that it works? So let's maybe be a little bit more professional about being sure that this works, and let's add some tests. So I'm going to switch over here to unit test. Actually, why don't we take it's been an hour, so why don't we take a 10-minute break and we'll come back and we'll start writing some unit tests. All right. So we started writing our credit check and we kind of implemented our first method here. And now we want to make sure that this is correct. And so we're going to formalize that because we're professionals now. So we're going to write unit tests. So Python has built into the standard library unit tests. There's a whole bunch of things in the standard library, a whole bunch of cool tools and utilities and basically specialized modules that are not a part of the core Python language, but that are available to you just when you're using Python. So with JavaScript, we have core JavaScript, and then if you want to use something else, you have to download it and import it. With Python, we kind of have 3 different levels. We have the core Python, and we have what's called the standard library, which is where unit test is, and then there's also third-party modules you can download and import. So the standard library, in order to use it, let's go ahead and just take a look at this first. So the standard library is a whole bunch of utilities, as I said, specialized functionality that the people who are in charge of Python thought were important enough to include, but maybe a little bit too specific to just make available by default everywhere. So unit test is one of them. Here's the official Python documentation. It's often a good place to look, but there's sometimes just a general internet search is going to get you better results than looking at the official documentation. It depends, but definitely one place that you want to look. So if I scroll down here, there's just a whole bunch of stuff. So before I start using this, I should read all of this and make sure I totally understand everything that's happening, right? No.
Absolutely.
Yeah. So if you did that, you would never get any work done ever. So another skill you have to learn is I need to use something. I have to look through this. What's the minimum that I have to know in order to start using this? So we're gonna take a look at the documentation. So it tells you that there's kind of 4 basic things. There's a test fixture, a test case, a test suite, and a test runner. I'm gonna skip to the good part and tell you this is really the only thing you need to worry about right now is test case. So a test case is the individual unit of testing that checks for a specific response to a particular set of inputs. So basically it's what we did with jest, and it's if I call a function with a particular value, I check that value. Does it equal this other thing that I'm expecting it to equal? Then if so, we're good. So here is an example. So it's nice, just like jest gave you kind of a minimal working example with the sum thing. Here we get a minimal working example. So notice that we have to import unit test. So this is how Python basically, it's not a part of the core Python language. You have to import it, but you don't have to download it. So it doesn't really require any work beyond just this import statement at the top. So we have to import it, and then we have this class. So this unit test library is object oriented, uses classes. I have this class right here called test string methods. And what's happening in here? So we haven't talked about inheritance yet. We will, but this is inheritance. So classes not only allow you to kind of define a template for the objects you want to create, but they can be kind of templates for other templates. So you can have a super class or a base class, something that sits up top. So if we're talking about filling out a form at the DMV for a driver's license, you might have a driver's license class, which tells you that you need to supply your name and your address and all that stuff. So that is very helpful. But if we also have like a boat, a boat license, something like that. I don't know if they do that, but a boat license, let's say. So a driver's license and a boat license. Again, there's a lot of similarities there, right? People are going to give you the name, address. So there's a bunch of common stuff. So if we just have 2 totally separate classes, one for a driver's license application and one for a boat license application, we're going to have a lot of repeated stuff in there. So what you can do there is you just kind of follow the same principles as you just pull that common stuff into an ancestor. So you'd have a super class called application or general application or something like that, and that's where you would specify name, address, common stuff, and then your driver's license application could say, hey, I'm actually a part of the general application. That means that the driver's license application can use anything that its parent has. So we'll talk more about that later. This is just kind of initial exposure, but so that's what this is doing here. So this class is saying, hey, I'm not just my own class. I actually have a parent class. So I'm inheriting from this unit tests test case class. So inside unit test is a test case class, which has a whole bunch of stuff in it that we don't need to really worry about. But it allows us to make our own test class, and it gets to use all that stuff for free. So we don't have to worry about it. We don't have to reinvent the wheel. We can just kind of use this stuff. And then if we look at the example, you can see, just like with jest, there's kind of a convention. So jest requires you to name your files in a certain kind of way. It expects certain things from you. And this framework is similar. So it expects your methods to be called test underscore something. So you have to name all your methods test underscore something, and then we have these assert statements: assert true, assert false, assert equal. There's a whole bunch of other assert statements. And where are these? So this assert equal belongs to the instance, so we don't see it here because we're inheriting from this, but in this base class, there's actually a method called assert equal. And we can refer to it. We can refer to it using self. Okay, so we'll just I'm just going to copy this. I'm going to go create another. I'm going to call this I'm going to paste this in there. I'm importing unit test. I'm going to get rid of these. And then I'm going to call this test credit check. I'm not getting. Okay. I don't know why I'm not getting the hyperlink stuff, but if you right click, sometimes command will work. I don't know why it's not working right now. And go to definition. You can actually see in the source code. So this is the source code, right? We're actually looking in the source code. So here's the actual test case class. And I'm not saying that you should necessarily, expect to understand this, because you shouldn't, but if you want to take a look at it, you can. And there's actually a description of what this class is. A class whose instances are single test cases, blah, blah, blah. So you can read this if you're curious about how, a real class looks. And there's a whole bunch of, what are these? What kind of variables are these?
Like class attributes?
Yeah, they're class attributes. And then here's the init. So this init is doing a bit more than what we're used to seeing, but you can do more than just assign variables. You can actually call methods and do other stuff here as well. It's a function that's going to get called when the instance is created. So you can call, different methods here, and we'll actually probably do that here. And then let's see if we can call some setup teardown. Let's see. There we go. So here's assert equal. So this is a method that exists in this base class that we're inheriting from. So we don't need to worry about that. But so under the hood, this is actually going to call some other method, and this underscore. This is all just FYI. This underscore indicates that it's a private method. So this means you shouldn't really call this from the outside. Here's the outside interface. So you, like us as the users of this, we just want to worry about this, but internally it's calling another method here. We can see. Let's take a look at that one. Follow the chain. So a lot of programming is just tracing, following the breadcrumbs to whatever source you're looking at. So here's get assert equality func. Get a detailed comparison function for the types of the two args. It returns a callable. What's a callable?
It's a function that you call, something you can call.
Yeah, basically, yes. It's a function. So Python has a dunder, surprise, surprise, a special dunder method called call, I believe it's called call. So you can basically add the parentheses. So you can pass in parameters or something. So basically it's a function, but it doesn't strictly have to be. And it's doing a type check here, and then it's returning something else. Self.base assert equal. So this like following something, which calls something else, which calls something else, which calls something else. It can be very messy, but that's often how it works. So here is where we're actually going to basically, the defaults are equal implementation, not type specific. So it's going to check for equality ultimately, and then create some kind of message, and then it's going to raise an error if they're not equal. So yes, so that's basically what's happening. You don't need to really worry about anything, but that's just, you know, if you are curious, you can actually look at the source code for this stuff. Okay, so the set test upper. We're not going to test upper. We want to test convert the list ints. And so if we want to actually call this, we're going to have to import it. So there's a couple ways to import in Python. You can just import the file directly. Import check. And then we could do something like so we could do that. We'd have if we just import the file, then we have to use this fully qualified thing. We can also do from the file name, import, and then what you want specifically. We'll do it that way. That way we can just say credit check, but either one works. Okay, so here we're going to create an instance of our credit check, and then and let's do, so what's our expected return from this? So if we pass in 1, 2, 3 as card num, what are we expecting to get back from this function?
List of integers.
Yeah. So specifically 1, 2, 3. Okay, and there's a couple ways to run this. I'm just gonna run the file directly for now. And the output is a little different from Jest. It's not quite as pretty, but same basic idea. So I'm actually printing something, so I'm gonna stop that. Okay, so I get 1 dot, which is hard to see here, but a dot means a passing test. So if you have a bunch of dots, that means you have a bunch of passing tests, and then we'll see what happens when they fail. But so a dot, which means 1 passing test. This is just a separator, tells you how many tests you ran, and basically did they pass. So I can change this if I want to see a failing test, and run this, failed, and it gives me detailed description. I get an assertion error, the lists are not equal, blah, 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 and then it tells me how they're different. Okay. So I'll go back to this. And ideally, we would write a few more tests and maybe cover some edge cases and stuff like that. But for the sake of time, I'm just going to leave it. Okay. So coming back to our credit check. So our credit check, we take in a list of digits. Now we can convert that to a list of integers. And we need to now what is the next one? First thing we do? Yeah, double every other digit. I have some every other. No one corrected me here. It's not some every other, it's double every other. Okay. All right, so double every other. How do you want to do this? There's a couple questions here. So since we have a class, there's a few different ways we could do this. And it kind of depends on use case. So our choices are going to be a little arbitrary. But here we're just returning a value. We could assign this to another instance variable, and that way we could use it everywhere. That might be one option, since everything else is going to use this. We really aren't going to use this anymore, right? We might want to save it for some reason or another. Another thing we could do is, since this is the init, it's just a function that's going to get run. And if we never need the actual string representation, we can just call this directly. So I'm going to do convert. So actually, I'm not gonna. I actually don't need the self parameter anymore. I probably shouldn't do this, but I'm just gonna go ahead and do it anyway. Just to give you some exposure. So I'm gonna mark this as a static method. You don't need to really worry about this right now. But so there's a few different ways we could arrange this. Here, what I'm saying, a static method just means I don't need self. This is just like a regular helper method. I'm just passing in this. This doesn't need access to anything else, right? It's just a normal function. It doesn't need access to self. So this is just kind of a helper method that I'm going to use to get things going. Does this make sense to anyone? And then self.cardnum, as soon as it gets created, it's already going to be that list. Any questions about that?
Yeah, so the only reason you're able to use that function in your init is because you made it a static method.
No, you can call any method in the init. I just made it static because it no longer needs to access. It doesn't need to access self.anything. So here I'm going to do yeah, so I'm going to have to pass this. So this is going to change my tests a little bit. You know, for the sake of not introducing too much confusion, I'm going to change my mind and go back to how it was. And then I'm going to add another. I'm just going to create another variable here. So self dot card num digits, and I'm actually going to call this so self dot convert list ints. Yes, so that should work. And I can keep that saying test, and I can also add another test to make sure that this variable actually works. So I'm going to add another assert statement here. So let's see. I'm making sure that the function basically returns the correct value, and then also that the this instance this instance property is correct. Okay, so I can do this all in the init, and that's fine. Okay, so I convert to list of ints, and now I'm going to double every other one. So how do I double every other one? Well, I can also use a list comprehension. I don't have to. So why don't we we'll just do it kind of like a more traditional style for this one. So we'll create a list, and then we'll iterate over it, and then we'll append to the list. We're going to iterate over so that card number digits. And then how should we handle this?
Could we say that if the index of n is divisible by 2, then double it and append it to double, and if not, then just normally append it to double?
Okay, good. So do we have access to the index?
Not in that loop.
Yeah, so how do we get access to an index?
You could do the enumerate.
Yep.
You could do a for loop with enumerate.
Yeah, exactly. And enumerate is actually going to return a tuple. Tuple, which you can think of as basically like a list. And can't remember if it's the first one is index, the second one, but we'll see. And then so if
The first one's the index.
okay, thank you. So if I modulus let's see. So we want the odd. So we're not reversing it, so we need the odd ones, right? Append. So we're going to append the doubled n. So n times 2. Otherwise, we're going to just append it. And then what should we do with this list?
Return it.
You can return it, yeah. Are we going to need to use this later?
Yeah, we should make it available throughout the whole instance. So self.doubled maybe.
Yeah, so let's go ahead and do that. We may be creeping up on an issue where we're kind of storing a bunch of stuff, but let's not worry about that for now. So another question is, how do we want users to interact with this credit check? So you can make a case for you just kind of create the instance, and then you have a whole bunch of methods available, so users have to know that you call double every other, and then add digits, and then check if this is by 10. So you can make users responsible for calling all these methods, which may or may not be what you want. It kind of just depends. I think in this case, we really only care about the final result. So I would say we probably are going to want to have some kind of internal method that's going to run everything together so that we get our final, the final answer. Yeah, so maybe yeah, let's go ahead and do that. So def run. So when we first create our instance, we're going to end up, this method is going to get called. So we're going to have our list of ints. And then we want to call double every other. Okay, so now we can actually do something like this. So the way we've got it set up now is we're creating the instance. So our string is automatically going to get converted to a list of ints. And then we have this, which is not going to immediately when it's first created, we're not going to know what doubled is. So we're saying for now that the way we want people to interact with this is they're going to create the instance and then they're going to call run. So we could eliminate that and just kind of call everything automatically internally. That will be fine. So there's lots of ways to do it. This is just one way. So we're going to say they have to call run, which means we're not going to know what this is when it's created. So this is going to get populated after we call run. So this is just kind of a dummy value. It's a stand-in. You can, it could be anything. You could do none. You could do an empty string. You could do anything there. You could also just not even have this. And this would get created when you called run. But I think this is a little bit clearer that this value is going to exist. So, you know, you should expect this object to have this value. Just makes it a little clearer. That's up to you if you want to do that. And if you want to experiment with different things, feel free. So, all right. So let's go back to our test to make sure that our double every other is working. So I'm going to copy this. I don't think I need to do that anymore. It should automatically get called. So this is going to return. This should return a value now. So and this is not going to be 1, 2, 3. It's going to be doubled every other, which means this should be 2, and that should be 6. If I run my tests, this fails. So why is this failing? Why is this test failing?
The way we grabbed the index when we doubled, we chose to grab the odd index.
Yep. Yeah, so if this is the index, so if I divided by 2 is 1, which means this should be 0, 1. Yeah, so what we actually want is like the 0 index and the 2 index. We actually want the even, right? So that means this is gonna have to be 0. And now the test passes. And again, we want to write more tests, but this is just initial. Okay, so now we can, we have our input, we can convert it into a list, we double every other, and then
I have a quick question. Just
Yeah.
I might be wrong here. So if we start at index 0, grabbing every other index, are we going to be able to get the very last index, which is what we're supposed to start on based on the instructions? Won't that miss the last index on certain cases if you start at index 0? I don't know. I'm just throwing that out there.
Yeah, so it depends. That's kind of a domain knowledge question. As it is here, I think if we assume that, so if we had, you know, more examples of numbers, maybe a variable length, that could be an issue. I'm
Okay.
just kind of assuming that that's not a problem right now, but
Gotcha.
that's a domain knowledge question. So that's something we should figure out before we started. I just kind of arbitrarily said, so we're not going to worry about it. Okay, so now we've got this. So now let's add the digits over 9. So we're gonna have to look and iterate over doubled. And if, so let's just go ahead and you can actually do the same thing. So so we need to iterate over doubled this time. We're assuming that doubled exists. And we can check. So if, what's the check we're going to do here?
If it's greater than 9, if n.
Okay. If n is greater than 9. Any ideas? Well, I think there's a sophisticated way of doing this, but I'm not going to do it that way. I'm going to convert this to a string, and then I'm going to, I think for now, just assume that it's not going to be more than 2 digits. And then I can just grab each thing. So we'll start with step 1. So I can just convert that into a string. And I can actually split this up immediately. So let me see. I convert it to a string, and then I want to split it and convert it. So I'm going to do this the complicated way, just for fun. This thing with lowercase. So so let me just comment this so we know what's happening. So if I have like the string 13, this is going to get turned into, or sorry, I have the number 13, my bad. So start out with the number 13, it's going to get converted into the string 13, and then that's going to get converted into a list of 1 and 3. And then what I want to do is convert these strings into digits. So I can, there's a couple ways to do that. I'm going to use a list comprehension just to torture you guys. So I'm going to convert that. So that will be int. So this now is going to give me 1, 3. And then I can actually get the sum. There's actually a built-in, which will give me the sum of everything in the list. So this, I'm just doing this Yeah, mostly just to torture you. But you can kind of combine stuff like this together in one step. This is not the most readable, so I wouldn't want to do this in real life, but you can do something like that. So that should work, I think. We'll see. We'll write a test to make sure that it does work. So sum dot append s else. And then I'm going to return that. We'll follow the same pattern. I'm going to go into the run, and I'm going to add. This is just kind of a marker so that we know that that should exist, and self added. Okay, so let's go to write a test now. So here we're gonna have to make sure that we actually call the sequence here. We're gonna rely on run ultimately, but for now we're just doing unit tests. We're testing each individual function, so we have to kind of call this individually. So we're gonna double every other, and then once we have the doubled, then we can call the add digits over 9. And so we're expecting now, sorry, so from 226, there's actually nothing that's going to hit for that. So let me change this to a 9. And so this should be 18. Actually, let me make this an 8. So that should be 16, and 1 and 6 is 7. So that should be, does that look incorrect to anyone?
Was it not 4 digits over 9?
Yeah. So if I pass in 1, 2, 8, this 8 is going to get doubled. So it'll become 16.
Oh, I see.
And then the 1 and the 6 will get added, and that should be 7. I think that's right, but if anyone notices an error, please speak up. Okay. Let's see. So we have an error. So list differ. Looks like I'm returning nothing here. So add digits over 9 is returning an empty. Let me just see. I'm not sure that I can. Let's see if I can add a break here. Yeah, I'm gonna have to set this up later, but okay. Does anyone see any obvious problem here? So creating the credit check instance, calling double every other. And the actual, let's see. All right, let me just, we'll run this here. And we'll see if we can, we can look at the output. Sorry. Okay, so print. this would be added. Excuse me. 1 second. Okay, so I get 227 here when I call this directly. So there's some issue with the order that I'm calling it in. So I'm gonna create the instance and call, let me split this just to make it easier to see. Okay, so here's my actual code. So I create the instance, which is going to call convert list to ints. And then I'm going to double every other. So what is the problem here? Does anyone see it?
Do you need on? Oh, never mind. Nope, I'm wrong.
So the problem is, this could be set up differently, but the way it's set up right now, in part to make testing easier, is that this method is just going to return something. So these are not actually connected. So if just by calling double every other, I'm not actually assigning anything to this doubled. That only happens in my actual run statement. So I'm gonna have to change my testing approach, assume that that was the case, which is wrong. So what I need to do is I have a couple options. I could just directly assign that value. So cc dot doubled is that, and this would be so 8. This would be 16, and this should work. That does work. So there's some pluses and minuses to doing this. We'll see different approaches as time goes on. But so here, I only really care about this particular method. I don't really care about the chain of other method calls. So I just want to make sure that, so I'm kind of artificially setting up the environment here. I'm changing the state of my instance to kind of match what it would be right before this gets called. All right. I think so. Let me just kind of try and knock these out quickly because we're approaching another hour. So I'll wrap up this lecture. Okay. So check if it's divisible by 10. We're gonna do the same thing. Let's do. Actually, we don't have to do that. So we now have all of our digits, added digits over 9 here. What we can do is so we can sum them. So sum self dot added, and we can just return. This is just like a Boolean, I guess. So return. Modulo 10. So this will be either just true or false, and we could actually assign this to an instance variable as well. Call it is valid. And we can also do, and we could have a default value. It is a Boolean, so I'll just make it default to false. And then display message. Let's do, so if you can check if it is valid or not. Whatever this message is, where was that? I'm not going to worry about the specifics, but return. All right, so we got the rest implemented. So let's go ahead and do this check if divisible by 10. We'll copy that. All right, so I'm going to create this and then doubled. So I want, let's see, I need to have access to added. I'm just going to use this previous one. And then I'm going to check if it's valid. So this should be false, I guess. Let's try that. Okay, so I would also want to come up with, maybe I'll just come up with something that would be true. So let's make this a 1. Yeah. So I'm just kind of hijacking this. This may not be valid for other things. So this is going to be true. Okay. So that method is tested, let's say, and then display message. I'm going to assume that this is kind of self-explanatory. Okay, so now we have all this stuff, and then if we were to actually use this, so I'm going to create another file here. So we've built our credit check class, and we've built our credit check class, and we've tested it, and so we're sure that it's working properly. So now if we were going to actually use this, we would do so I'm going to import it from credit check, import credit check, and then I'm going to use this example. Hopefully that works. So CC equals credit check, and then I'm going to call run. So CC dot run. And let's make sure. So run is going to call to self that is valid. And then I'm just going to call display message. Python. So I get is valid there. I could try it with something else. Not valid. So looking like that works. Our test could, we could have lots more tests, but that's the basic idea. So I think all of you implemented this as just one method, which is, it's fine, but it makes it impossible to test any of the details. And if things need to change, it's just, it's a good habit to start thinking about testability as you're writing things. Okay, any questions? I know that was a lot, and that was a long lecture, so. All right, I'm gonna stop sharing. And let's see. So for the challenge, why don't we take a 5-minute break and we'll come back and I'll talk about the challenges. So 5 minutes and we'll come back.